Let me first introduce the topic before I invite the panelists to the stage. Basically, context as to why Intuit is so passionate about hosting this session. Intuit is a 30-year-old SaaS company. We are continuously transforming ourselves, and we are committed to winning in the cloud. For more than 3 decades, we've navigated several platform shifts, from DOS to Windows, to the web, to the mobile, and now to the cloud. And in every instance, we have seized the opportunity to reimagine our offerings and deliver the most value for our customers. Now, we've actually been delivering cloud-based services for over a decade, with tens of millions of Intuit customers using them across the globe. And how have we done it? We've done this by primarily partnering with an industry-leading provider, which is the Amazon Web Services, and they are a key part of our transformation journey to the cloud. We are leading the way for other enterprises and helping to unlock the possibilities of the public cloud for companies, for industries, and for our customers. What we are attempting to share here today as part of this panel discussion is our experience in migrating to the public cloud, the principles, the challenges, and the learnings that are required, and those that you can take away as key takeaways to achieve the broader cloud vision. With that introduction of the topic, I would now like to introduce the panelists. My first panelist is Soumendra Das. He is the Chief Architect at the Intuit India Development Center. He's been with Intuit for about 10 years. He's seen all the transformations that we've made in the organization. He's held both engineering management as well as architect roles in the small business groups as well as the central technology teams. A geek at heart, he's passionate about all things tech, and his current passion are computer languages and functional programming. Das, please come back. My next panelist is Linu Matthew Koshi. He's a principal engineer working at Intuit again. He's been with Intuit for 11 years. He is currently working on the QuickBooks online accounting product. He is one of the security architects in our transformation to the cloud, and he has been involved in moving one of our core products, which is QuickBooks Online, to AWS. Prior to that, he's also worked on one of our other offerings, which is Mint, which is also hosted in the cloud, and a couple of other SaaS offerings at Intuit. Lino? My third panelist is Vishy Ranganath. He is the Director of Product Development in the SBG platform organization. He is actually responsible for the evolution of SBG services in support of our global offerings. And he has over 20 years of experience in technology industry. He's a BTech from IIT Chennai and a master's from the University of Arizona Tucson. An engineer at heart, he is passionate about science, math, and philosophy. Vishy? So the question to the panel, right? Intuit's been in the business for about 30 plus years. And today, while cloud is a mainstream, we've been one of the earliest companies of this scale with enterprise class data who attempted to move to the cloud, right? And Intuit has been very successful, given your business growth in the last decade. What was the motivation for Intuit to really move to the cloud?
Thank you, Cynthia. Are you able to hear me through the mic?
Yes.
Okay. So thanks for inviting me here. The thing to keep in mind is that Intuit is a very old company, more than 25 years, and Intuit has built its business on desktop software for most of its life. You know very well the limitations of desktop software. There was a time when that was the only option, but now we have so many other options. And since we want to be global, we are undergoing 3 major transformations that will make us a world leader. One is that migration from desktop to online, so that we can reach all customers around the world. The second one is a transformation from application development to platform development and building an ecosystem. And the third one is US only customers to global customers. Now obviously, to achieve these 3 things, you have to get out of the desktop software business and go online. So that's the first thing that we need to realize. Then the next thing to realize is that when you function on such a large scale with millions of customers around the world, the data center that you need to run to host all your services, that's a non-trivial operation. And it's also contextual to what we do. We solve financial problems for customers, and we try to simplify their financial lives. That's our focus should not, that is not, that's what we should be spending time on, and we should not be spending time on contextual things like infrastructure and hosting. So that's where the opportunity to move to the public cloud comes in, where Amazon can take away all these worries from us if we do it right. So that's really the motivation for moving to the cloud.
Yes. So before we go into the details of our journey, let me talk a little bit about the framework of how we think about at Intuit when we're trying to bring about such a massive transformation as going to the cloud. Okay? And we think of change management we're in the shoes of three critical shareholders: our customers, our shareholders, and our employees. And we talk about this change going to the cloud. How does it benefit our customers? How does it benefit our shareholders? And how does it benefit our employees? And that really lays the foundation of our transformation. So the benefit for the customer actually is a very straightforward one. Going to the cloud means it is more or better availability and resiliency, better experience for them, and better latency. So for example, if you are a customer in Australia and the data centers is running in US, you do have to cross the Pacific Ocean, right? And that doesn't lead to a good customer experience in terms of latency. So that's the customer benefit. The shareholder benefit is that going to the cloud has a dramatic reduction in our capital expense, in the way we procure and manage our equipment and hardware. So that's the real shareholder benefit. And the third benefit, which is in my mind the most important benefit, is that for our employees. Going to the cloud dramatically increases our velocity, right? Our teams can move very fast, right? We can very rapidly innovate and experiment. And when you can move fast and experiment faster, which means that you can deliver benefits and features to the customer that much faster, right? So again, it is all about velocity, and we always keep in mind what the customer benefit is, what the employee benefit is, and what the shareholder benefit is.
Thank you, Das. So cloud's been a buzzword over the decade, right? I mean, we've heard of so many things: private cloud, public cloud, hybrid cloud. So nobody has really have a perfect solution to the migration to the cloud. And it's been a complex journey, right? Intuit was one of the early companies to start doing this when really there was no blueprint readily available, right? So how did Intuit really crack it, right? In terms of the technical approaches, so how did you actually do that?
So there are really, okay, so Intuit is in a very interesting situation. So most of the companies today who talk about going to the cloud, they're actually going to the cloud from zero. They are starting in the cloud. We are in a very different situation. We already have a very thriving business, which is running out of data centers. It is revenue earning. There are actually millions of customers who are running their entire lives depending upon Intuit. And you have to really think about all of this when you're trying to go to the cloud. So in general, if you are already an established player running out of a data center, there are really two ways you can move to the cloud. The first one is what we call decompose and shift. And that means that you take your old monolithic legacy system, which is in your data center, break it down, make it completely cloud ready, and then you move it to AWS. That is one approach. The challenge with this approach is that it can actually take a very long time. The second approach, which is the approach that we favor, is what we call lift and shift. Okay. So lift and shift, the name actually is not completely accurate because we actually do not lift it exactly as it is. But the way you want to think about it is that what is the minimum changes you need to make, right? The minimum viable cloud application that you need to build, right? So get the bare bones changes done, just the minimum changes. Maybe it is something to do with security, something to do with deployment, something the way you build. Move is as quickly as possible to the cloud. Once you're in the cloud, you will actually get real life data. You will learn from it. Oh, this is not really the way it works. Oh, there's actually some Amazon service that we can use better. And then you refactor it in the cloud. Okay? So these are really the two approaches. Okay? And the approach that we took actually is lift and shift.
Linu, do you want to add to this from a quick QBO experience?
Sure.
Yeah, just to add on to what Das said, like these are the two main approaches, but you can use hybrids in your application also depending upon how mature it is and things like that. In the case of Intuit, one of the products we're working on right now, it's called QuickBooks Online. It's a monolith. And when I say it's a monolith, it is a huge binary which we deploy in a single deployment. And the initial approach was let's decompose it because we wanted to go through the decomposition journey, and then we'll move to AWS, right? So we were trying to solve two things together, like decompose as well as move to AWS. We started the journey like 2 years back, and we couldn't make much progress on that actually. So that is when we took the pivot to the second approach that Das talked about. Actually, let's do a lift and shift. And that's worked beautifully for us actually. So we are separating the concerns, we are moving to AWS first, and then we'll do our re-architecture there. So that's one of the...
Thank you. So, we've kind of faced some hitches at Intuit in terms of moving to the cloud initially when we took the approach of decompose and move, right? And so obviously there are some learnings why this approach really did not work. So Vishy, you were part of that journey. So do you want to share your learnings with why decompose and shift really did not work? And
Sure. So building upon what Das talked about, the thing to, the perspective we need to keep here is that, again, being an old company, there were multiple business units. Each business unit had evolved its own offerings in its own way in complete independence and autonomy. So you can imagine what happens when you have an organization like that. There was a lot of duplication of logic that could have been centralized. There was a lot of disparate technology choices because each BU made its own decisions about what platform, what technologies to use. So we ended up with a highly complex landscape of technology that we have, which obviously you don't want to transplant completely into the cloud because it's against best practices and it gets in the way. What we want is a clean microservices architecture with shared services, no duplication of logic, no clones. We have a theme called attack the clones actually, or kill the clones. And what we realized was doing all that was necessary and it was taking too much time to do. Also, bear in mind that our code bases are very large. We have monoliths that Linu talked about, which are in millions of lines of code. And cleaning that up and breaking that into reusable components and services, all that was taking so much time and coordination that holding the cloud journey hostage to that was not the right choice. So we said we'll take it as it is to the cloud with the minimal changes that Das talked about, and then we'll continue our tech refresh journey over there and move from using Amazon just for infrastructure to eventually all the platform services of Amazon, which can actually reduce our footprint. I hope that makes sense.
Thanks, Vishy. So obviously the first approach did not take off too well and you had to kind of step back. Now, from those learnings, there would have been some guiding principles, framework, etc., which would have kind of defined the strategy and thinking in doing the lift and shift approach, right? So is there something that you can share with us on what would be the key guiding principles and takeaways?
Yeah. So I think the first key takeaway is that when the CTO says go to the cloud, it is like the Bangalore traffic jam. Every engineering team wakes up and says, yeah, let's go to the cloud. And before you know, there's like 100 projects have spun up, and every engineering team is trying to figure out how to go to the cloud. It is like this Bangalore traffic jam. There's no other way to describe it. And actually, that is exactly what happened. Everybody tried to go at the same time, and then we said, hey, look, this is not going to work. This is just not going to work. So we actually took a step back. So what we did was we actually established two types of guiding principles. Okay? The first one are what we call the principles for cloud architecture. That once you are in the cloud, what are the principles governing the way the system should be architected in the cloud? That is step one. The second one is principles around what we call cloud enablement. And these are the principles and rules around how do you enable an existing system from the data center to move to the cloud. So again, two sets of principles. One is how do you architect for the cloud? The second one is how do you move into the cloud, right? And these are the principles that we go and relentlessly apply and work with every team to make sure that they are moving to the cloud in a very consistent way. I probably will not be able to go into all the principles, but let me give you a flavor of those. Okay? I can talk to the
Yes.
Architects have a habit of talking
Too much.
So managers keep us in check. Okay. So one of the cloud architecture principles is that everything will fail, right? So you just have to design for failure. Your hardware will fail, your equipment will fail, your network will fail. And there's a very famous saying by Werner Vogels that says that if you design for everything will fail, then nothing will fail. And that is something that we take to heart. Right? The second thing that we take to heart is do not trust the computing environment. Okay? Nothing is secure in the cloud. Okay? So when you are in the data center, it is like being in a fortress. You know, you are in a fort, there are gates, there are high walls around you, there is a moat filled with sharks and crocodiles. Well, sharks or crocodiles, not both. And there are gatekeepers, you know, and they control who comes into the cloud and into the fort or not. But inside the cloud, inside your fort, you trust everybody around you, right? That's not the way it is in the cloud. You don't know who is around, who is next to you, right? You must be extremely paranoid. You cannot trust your machine, you cannot trust your network, you cannot trust your compute, storage, and everything you have to be very, very suspicious about. Is this really going to work? Is this really going to be secure? And that is the highest level principle. When we are talking about migrating to the cloud, there are really three main principles that we talk about. The first, the move will never happen in one day for a huge system like us. During the move, we shall not compromise on the customer experience. The customer's experience in terms of latency, functionality, performance will never be compromised. Second, we will never compromise on the integrity and the data, integrity and the privacy of the customer's data. See, look, we are a financial company, right? The only asset we have is trust. You lose your data, you have anybody here has a Yahoo account? Had a Yahoo account? Yeah, remember how you felt when you saw the news that your account got hacked? Imagine what that does, right? So we take our data integrity very seriously, right? And the third is that identify the risks very carefully on how you move to the cloud. Be very thoughtful about it and have risk mitigations planned for each one, right? So again, architect for the cloud, right? And in there are two principles, okay? Do not trust the computing environment, design for failure. Then the second set is migration principles, and there it is, make sure that the customer is always up, do not compromise on security and privacy of data, and third, have risk mitigation.
Thank you, Das. You said don't trust anything, right? Obviously, you are in a public space, and the first question is, how do you know that your data is as secure in the cloud as it is in your own privately owned data center, right? So how do you enable security for your data and IP in the cloud? Linu, you're a security expert.
So before I answer what we have done, let me talk about why, like Das talked a bit about it. So why are we saying do not trust the environment, right? So if you look at the migration journey, we are going from our own data centers where we have full visibility and control on things like, you know, the people who are accessing it, we know how the cables are laid, we know how the machines are disposed, everything we know about it, right? From there we are going to AWS where we have very limited control and visibility on these aspects. Can somebody wiretap in the AWS environment? We don't know. Can somebody maliciously make access to the RDS instance? We don't know about it, right? So that is why we are really paranoid, and that's why we came up with this principle, do not trust the hosting environment, right? So we do a bunch of things, and I can talk about few of them as an example. One is encryption. We do a lot of encryption in our systems, and we do encryption at different layers. For instance, we do transport layer encryption. Any machine-to-machine communication is encrypted, so even if somebody is wiretapping, there's no information they can get. We encrypt all the disks that we are using, so that even if somebody pulls out a disk and moves away with it, they cannot make any sense out of it, right? We encrypt the data in our databases. Every data which is highly sensitive and secret, we encrypt it to make sure that even if somebody looks at the database, what they see is encrypted garbage, nothing else, right? So this is the encrypted related things we do to make sure that our customers' data is secure and safe. We do a lot of monitoring also actually. So if you look at security, right, there's a lot of things you can do to prevent it, but it's never complete actually, because every day people come up with new hacks, new vulnerabilities. Your system is always vulnerable. What makes your system smart is how fast can you monitor, like how is your monitoring mechanism, how fast can you detect an intrusion, and how do you recover from that, right? So we have invested a lot on these intrusion detection services, both in-house and third party. We use a lot of that to monitor systems. We also follow the architectural patterns like swim laning, sharding, so that even if in the worst case of a compromise happening, it's very contained. It's only a few customers that are impacted, and we know who's impacted and things like that. So these are a few examples that we follow to make things work.
Sure.
Just like to add a quick thing here. Obviously, if we are encrypting, we have a lot of keys to manage, and the key management part is extremely critical, and that's a whole different level of security. So Linu has done a lot of awesome work there on the strategy to manage keys safely. And what do you do in case where keys are compromised, right? So it's actually a very interesting and complex problem for a technical mind to solve.
Thank you, Ishi. So there are two aspects of it. One is security, the other is also equally important is compliance, right? So does moving to the cloud, has it caused Intuit to change any of the security and compliance standards, if we may call it?
Yeah, thank you, Cynthia. So first of all, viewed externally, nothing changes. So all the compliance standards that we follow externally, whether it is government regulations or data standards, privacy policy, security policy, PCI, DSS, we are a company in the space of simplifying financial lives. We have credit card processing. We have functions that require a completely different level of security, and therefore we have to undergo these yearly checks and audits from various institutes that basically are responsible for certifying organizations. None of that changes. That continues from year to year, whether we are in our own data center, or we are selling desktop software, or we are in the public cloud. But by going to the public cloud, our risks and our dangers have completely increased, like going from a fortress to an open battlefield, right? So being in the open battlefield, what we have to do to achieve the same level of security and compliance is orders of magnitude different. So going to the public cloud, in short, has increased the amount of work and thinking we have to put into securing our customers' data, whether it is at rest or in transit, and of course keeping the access control and protection is also at a completely different level.
Thank you.
Yeah.
The one of the things is Intuit's been in existence for a long time, and like any other enterprise organization, your products have also evolved over a long time, right? And we sometimes tend to deal with legacy of architecture, legacy of the growth of the product itself. Now, cloudification, if I may call it, the journey to the cloud, in some sense affects both the life of the people who build it and the people who operate it, right? So what does it mean for people like the community that gets impacted, like the developers, the test engineers, the operations people? So what exactly does it do to their life? Das?
Sure, yeah. Das and I can talk about this. Lots of changes. So I'll look at this from the perspective of the engineers who are doing development, right? We have, in a traditional company, we have developers, testers, operations, and they tend to operate in silos, especially operations and developers tend to operate in silos. But when we go to the public cloud, the biggest change is that now infrastructure itself has become code. And the proportion of code that we write, in fact, the infrastructure code may be a very large part of the overall code that we write. And developers actually have a lot more control. So we have an opportunity to reorganize ourselves where the DevOps separate organization mindset goes away. We have a DevOps mindset for a single team. Imagine a Scrum team that owns things end to end, that they can actually provision environments on their own. They can manage the CI/CD pipeline themselves. They can code, test, build, release, and get it into production, customers' hands. So all that becomes very fast and very achievable because the entire thing is code, and environments, everything is virtual. You can pretty much provision everything yourself without having to depend on anyone. So that's the biggest change. The second change, which I cannot overemphasize, is the security mindset. What things that a developer takes for granted, like I'm in my data center, I can do whatever I want. There is somebody else to protect the data center. That mindset needs to go away, and I think Das can talk more about that.
Yeah. So what Vishay ended with, I really want to echo it back. The way an engineer approaches security for a product in the cloud is radically different from the way they would approach it in the data center. In the data center, you are in the fort. I mean, if you just that fort analogy is really, I think, the best analogy we can think of. You are in an open battlefield. You cannot trust anything. Every endpoint must be secured, and this has to be internalized by every developer who is writing a cloud application. Okay? So that is the first thing. But to go back to the cloudification question that Cynthia asked, okay? Let's ask the more fundamental question, that why did we go to the cloud in the first place, right? And the short answer is that we went to the cloud for speed, for velocity, for agility, right? That is really the primary reason why we went to the cloud. So it's like if you have a Ferrari and you're driving it on the streets of Bangalore, well, that may not be the most optimal experience, right? So if you want a Ferrari and you want to get the best out of a Ferrari, you need to be driving it on a racetrack, right? Now for engineers, what that means is that you need to build speed into every aspect of your work. The way you code, the way you unit test, the way you build, the way you do QA, the way you deploy, right? And because when you're in the cloud is actually provisioning the network there is so fast that all these bottlenecks will just show up in a very glaring way. So you have to increase the velocity through the entire software development lifecycle. And what this means in real life is relentless automation. You just have to brutally go after anything and everything that is being done manually and just automate the heck out of it. And what this means is that if you have people configuring stuff, no, that must go away. Okay, it must be configuration, must be as code. Configuration is a code, right? And those are examples of so in summary, relentless automation is something that you have to put in your team's mind. That is the only way cloudification is going to succeed.
I just add one quick thing to what Das said. I have developed a thumb rule over time on what can be automated, and it's very simple. If anything is done a second time, it's a candidate for automation. It's as simple as that.
So would you also want to touch a little bit on, looks like the lines are blurred between dev and test and DevOps in the cloud, right? You talked about a developer. What does it mean to a test engineer to be able to build and test in the cloud?
Is that for me?
Yeah.
Okay. Yeah, so first big change that we should all accept is that I think that the days of pure functional tester are over. A tester who does not have technical skills but knows how to test a product functionally, manually, those days are over. That function is important, but having a person who does only that is not going to work anymore. What we need for, I think, QA, quality assurance organizations should transform themselves into being QE organizations, quality engineering organizations. In fact, I believe that you don't need a separate QE organization. I think you can actually centralize all this under product development directors. However, from a test engineer perspective, you need a combination of skills. You need functional knowledge, assuming that you own functionality in the product, but you also need a lot of technical skills that which includes coding, which includes knowledge of public cloud and the tools and services and infrastructure that, how you configure it, how you use it. Even things like unit testing, which we traditionally say that only the coder has to think about and not the tester. I think testers have to be close enough to that also, because these lines between unit testing, integration testing, system testing are all blurred now because of agility and how we can. It's possible for even large organizations today to code and deploy to production on the same day. And Facebook does it, Google does it, and we are on the verge of doing it actually. So that's what it means for the quality engineers.
And that actually drives the agility, right,
Yes.
of your releases.
Can I add a comment to that?
Yeah.
The way you want to think about is being fast and fearless, right? See, whenever we are trying to deploy new code into production, there is a fear, right? How many of you have that gut-wrenching fear? Is that right? Right, exactly. Before setting into production, there's that butterfly in the stomach. See, that is the real issue. Is that how do you make it such that it is fearless? Is that, yeah, you know what, yeah, I'm pushing a button, it's going to go to the cloud. By the way, we actually do data centers flips from one data center to another data center today. Okay, it can actually be done by our SVP. Our SVP actually does it. He literally walks in, he executes one command, right? And the entire application switches over from one data center to another, right? And that is like, oh yeah, I'm trusting my SVP to do this. And that actually says quite a lot about what it means to be fearless.
That's fast and furious, not fast and fearless.
Well, if it doesn't, the failover doesn't happen, the SVP will have a conversation with you, so maybe. but going back to what it means for QA. When you are operating in a data center, there are a lot of restrictions that you live with. Okay? You have one QA environment, you have one perf environment, you have one E2E environment. That goes away in the cloud. Okay? You want 5 end-to-end environments? Fine, spin them up. Right? Tear them down 2 hours later. Right? But if you want to use it effectively, you can't spin up an environment and then start testing it manually. That's not going to work. So which means that just like the cloud gives you the power to spin up an environment in 15 minutes, you now need to automate the heck out of your test procedures as well.
Yeah.
Right?
Yep. Thank you. So one of the primary requirements of the business is availability and uptime, right? I mean, we tend to think that we have control over everything when it is in our own data centers. Now, availability and uptime is definitely a key criteria when you host your offerings in the cloud, right? And resiliency is a key factor that impacts availability and uptime, right? How does the cloud really enable you to do that? Linu, you want to take that?
Sure. So that's an important question because many a times when we go to cloud, we assume that things are done for us, like many things come for granted. That's not the case actually. If you look at resiliency, there are 2 types of resilience at a very high level. One is infrastructure resiliency, the other is application resiliency. Infrastructure resiliency, Amazon gives you a ton of stuff there. It supports a lot of it. Like you have the multiple availability zone pattern you can use for deployment. So you deploy in different ACs. If things go down in one AC, you get your capacity back in the other ACs. You can even use a multi-region pattern for deployment to make sure that your application is highly available, resilient to infrastructure failures and things like that. But if you look at the application resiliency, some things Amazon does give you. If you're using their managed services, there's a lot of resiliency they give by the uptimes and all they promise. But the dependencies you have on services downstream, you have to manage it. And Intuit has invested a lot on resiliency. We have been working on resiliency even within our own data centers. We use frameworks like Historics and all, and this is work we have done long back itself, even without going to AWS itself. So resiliency, AWS does help a lot, but there is a lot of stuff you have to do in your application. Just to touch upon the availability part, actually, one of the questions we get very often is you're migrating to AWS. How do you make sure that your customers are not impacted? Because there's a huge switch from one data center to a totally different environment, totally different beast, right? So how do you manage it? The answer is that we do it in a very phased and controlled manner. So all of our products have the swim lane architecture. Swim lane is a logical grouping of users at a very, very high level, right? So what we do is that we take one swim lane at a time. Let's say we are taking swim lane number 1. And that again we take in a very controlled manner. For instance, swim lane number 1, we take it for 1 hour during non-peak hours when we know that it's only 10 customers who is using it at that time. We go to AWS during that time. We look at the errors, the latencies, every number. If anything is really bad, we come back immediately. If things are okay according to our expectation, we stay there for 1 hour. Still we come back to our data centers. Then we extend the time period. We go to 3 to 4 hours. Then we extend it to 8 hours, 1 day. And once we are really comfortable, we leave that swim lane in AWS. And then we come back, tackle swim lane number 2, swim lane number 3, so on and so forth. So that way we know clearly how much customers are impacted. It's a very, very small fraction that is impacted, and we are really available for the majority of the customers. So that's the approach.
The tiptoe technology.
Yeah, we call it the
tiptoe
tiptoe
principle.
Exactly.
We also talked about, you don't want everybody to do things because there are common services required, right? With codification, patterns, and everything else, right? So when you have hundreds and thousands of developers building products in the cloud, everybody is supposed to be using some common services. What are the principles of governance and management that you need to keep in mind so that your product becomes actually maintainable, right? Maintainability with respect to both development as well as operations.
Yeah.
Do you want to take that?
Sure. Yeah, I think I can start that off. The first approach that I would take, and this has worked well for us, is when you think of a service, you need to think whether it is domain specific or not. So we know what domain we are in. We are in in the business of solving problems for small businesses. We have accounting, we have payroll, we have payments, we have various other services, and you can tell over a period of time whether something is specific to that domain or not. If I'm building an accounting specific service, then that's specific to the small business group. However, if I'm building a printing service, then obviously that is common and can be used by anybody. So when we apply that criteria, what we find is that a lot of services that business has built as part of the domain can actually be centralized and reused by others. So when we apply these criteria relentlessly and uniformly across all BUs, we will be able to move services down or up, depending upon what happens, mostly down, and in that process kill clones, and then we have a single service maintained by a single team that everybody is consuming. So as we do that, we get more centralization, and we have fewer services. So that's the criteria that we used, and that way the business specific layer becomes thinner, not like really bloated like it used to be.
So, yeah. So just to building on what Vishy said, taking a single service to the cloud is actually pretty straightforward. So if you're a small company, you have got one Kutti service, you're trying to take it to the cloud, that's relatively straightforward. The problem starts happening when you are a large company and you're trying to move 100 or more services to the cloud. And these are different levels of maturity, different organizational structure, and just tell 100 engineering teams go to the cloud, see what chaos happens. Every engineer goes, they will come up with their own design, every guy has their own way of doing security, everybody has their own architectural pattern, and before you know it, it is a whole big mess, right? By the way, to be completely transparent, yes, we have seen some of that, right? So one of the things that we have said is, we do not want our engineers to be focusing on common concerns like security, like encryption, like monitoring, deployment. These are common capabilities that are concerns that are needed by each team. And that is what we said, that they must be done in one way, by one team, do it the right way. And do it in such a way that it works for everybody. So that is the first thing. The second thing is that when you're trying to go to the cloud, just like in software, we have design patterns, right? Remember, we have design patterns like a strategy pattern or an observer pattern, right? We have done exactly the same thing for the cloud architecture.
Yeah.
We actually have created a library of architecture patterns. So now every team can actually say, well, I am trying to build like a streaming service. Good, fine. This is the kind of pattern you should use. I'm trying to do data acquisition, but I'm a compute-only capability. I don't have any storage requirements. Good, fine. But I have a high elasticity needs. Good. You use this pattern, right? So we actually have created a library of patterns. Okay. The good news is that this is the first version was created by our central architects, but it is actually an open contribution library. So as teams go and they discover improvements to that patterns, or say, hey, we have found a better way to do it, they actually contribute back, right? These patterns have been reviewed by the senior most experts. They are secure. They are actually conforming to all the principles and all the good things that we know about the cloud. So that is the first thing. And the second thing, I think we touched upon that earlier, is that common concerns, be relentless about doing it once. It doesn't help anybody if there are 3 teams trying to write encryption software. It is just a complete waste of time, right? And this is why governance has to come in, right? Okay. People see, actually, engineering is a lot of it is about talking between people, right? Teams must talk to each other. How do we do things in a common way, right? And if you think about architecture, it is really about hitting the balance between the short-term benefits and the long-term doing the right thing. Okay? And this is why we have established a lot of governance and principles around how to do all of these things.
Just one quick thing to add there is, since you talked about governance, we have something called the Intuit Service Portal, which is a place where you can go and look up all the services that are already available. So if you're a developer, before you build anything, that's the first thing you're expected to do. and then you pick up and reuse services from there, and you build on top of those services. You don't rewrite anything. So you get a launch pad. You're not starting from zero. The second thing is about meetings. Even though conversations between engineers are very important, we are actually trying to get to a state where you can build a service without ever having a meeting. You should be able to go pick up a service. That service should be in such great level of maturity that you can simply use it without even asking anyone. That's our goal, and we have achieved it in many places.
Thank you, Vishy. I know architects don't like meetings, so.
They like talking, but they don't like meetings. Yeah.
So the other thing is, now as we discuss the different facets of what is involved in moving to the cloud, very clearly it has started impacting, and it will impact the future of the business in terms of people, the mindset, the competencies, and everything expected to make this journey successful, right? How do you really build the organizational capability to be able to do all this successfully?
Yeah, sure. I can talk about the mindsets maybe first, and Vishy, maybe you can add to that actually. So many of the mindset changes we already talked, like not creating duplicates. That's a mindset change we have to drive across the organization. Security is another thing. Do not trust the environment. Those are like the fundamental things we have to drive across. Another thing is that people are not used to working in these dynamic environments. If you look at AWS, this is because of auto scaling and maintenance. Machines go down and come up all the time, right? You are not architecting or designing in your own data centers for that. And in our initial products we had a lot of issues because things were left in an inconsistent state, things were left in a hanging state, all of those things, right? So we needed to like train our engineers to how to design in cloud, like how to design in such a dynamic environment. That's another thing we did. Another mindset change, or one of the principles we are trying to follow, is like, try to solve the hard problem first. So typically we always tend to go for the low hanging fruits. That's easy because like that's an easy one to do and we can show progress. But in Intuit, what we are trying to do is, we're trying to go get the fruit at the top of the tree, because we believe that this is going to force us to make the ladder. By the ladder we mean the organizational capability, the technology, the processes, which will help us gather all the fruits actually. And this helps us uncover all the issues in the beginning itself. And another add-on to that is, if you're going for a very complex problem, you need to learn how to break into smaller pieces, because everybody won't be able to get the big picture and solve it in one go, right? So break it into bite-sized problems and then let the team solve these smaller problems. So these were a few of the mindset changes. Maybe some other thoughts.
Sure. Thank you, Lino. So I think we touched upon many of these things already, but the thing that comes to mind right away is organizational silos break down as we move to the public cloud. We completely outsource a whole bunch of things that are contextual to what we do. We are able to use infrastructure and platform services like we use electricity. You just switch on something and you get electricity without having to worry about how electricity is produced, right? Something like that. Organizationally, it's a new opportunity for us to completely rethink our org structure, have fewer layers and fewer specialized functions, and have fully empowered Scrum teams, where understanding the customer's problem, writing the software for it, and then easily getting it out into customers' hands because of all the infrastructure code that's available with public cloud. That becomes possible. So the nirvana state is basically Scrum teams are highly empowered, and we have less hierarchy and less centralized, less dysfunction in the organization. That's the way I would say it.
So one quick question, right? There have been some companies which have kind of tried to go to the cloud and then gone back to the data center. Example of, say, Dropbox or even Citrix in the recent past, right? What is the takeaway for us, for this audience, with respect to that experience, right?
Sure. Yeah, go ahead, please. Yeah.
So going back to your own data center. So the question, so you really have to answer two questions, okay? And maybe Lino, you can give the specific example, right? First question, why did you go to the cloud in the first place? Did you actually have clarity on why you were going there for the first place? Of course, if you went there for velocity, you're not getting the velocity, okay, maybe you can move back. The second question is, what is core to your company and what is context to your company, right? And if you do not have clarity between those two, okay, you may discover that you actually went to the cloud for the wrong reason, right? The example that is cited often is Dropbox, right? And maybe Linu, you can give the specific example of why they moved back.
Sure. So if you look at Dropbox, and they have like multiple blogs about it, like they had like very specific storage reasons which they wanted to solve. Like they were not happy with the data density of storage in Amazon. They were not happy with the write speeds, the read speeds. So they had to go back to their own data centers for that specific purpose. So if infrastructure is like really core to you, you might not want to use this Amazon S3 or solutions like. But if you're not really bothered about the infrastructure at that level, which is like companies like Intuit don't really care about the infrastructure at that specific level, Amazon is a good fit for you. So you need to evaluate for your own company. So if hardware is really important, you might want to stay in your data center, solve it specifically using your own technologies, otherwise Amazon will fit. And actually, if you look at the Dropbox blogs, they actually say that nowadays Amazon is fitting their requirements, but they have already made the journey of going back, so they're staying there. So,
thank you. So I know we can keep talking. This is a vast topic. So my final last question to the panelists is, just to summarize all the discussions that we've had, what are the few takeaways for this audience? Maybe we can have each of your panelists respond.
sure.
Start with Das.
Yeah, so from an architecture point of view, my advice would be that have absolute clarity on what your target state architecture in the cloud looks like. Be very thoughtful about how you're going to move. Be very thoughtful about having checklists about readiness that you can move. And if you have clarity on where you want to be, and where you are, and how you plan to move step by step, you are going to succeed. But if you do not have that clarity along the way, then your mileage may vary.
You want to add, Vishy?
Yeah, so I think the biggest takeaway is that it's a huge opportunity for anyone who's trying to build any online service. If you're a startup, it's a no-brainer. You have nothing to lose. It is the best way for you to get your service online. You don't invest in hardware. You don't invest in data center. And for large companies, my takeaway is that it's AWS is mature enough for large organizations like Intuit to also transition to the public cloud, provided they do not have very specific infrastructure needs like Dropbox. So it's a huge opportunity and we should exploit it.
I can add a couple actually. So I already talked about it, but I can't stress the importance of security, like, really keep security in mind. But one advice is like don't go too theoretical or unpractical, be pragmatic about it. And the second thing is, especially in the case of AWS, try to understand which is your hardest problem and go behind it, because that helps you uncover all the issues in the beginning and makes you and the organization prepared about what you have to face eventually. Right? So,
thank you. Hopefully this discussion gave you a flavor of what it takes to make this journey. We'll now throw the floor open for questions from the audience.
What was the change in the release model, and how were the releases managed with the migration to AWS?
Sure. Maybe you can also take this. Since I earlier talked about the teams being more empowered, what happens is that we can actually have a much more decentralized way to release. So we have complete decomposition. Decomposition is not a bad word. It's a bad word in the environment, but in software it's a good thing. So the decomposition that we have on the platform, we have decomposed into microservices. On the UI, we have actually decomposed the UI also into plugins. And now each of these pieces can be released independently without destabilizing the entire system. So now since we have a large number of things, we are moving away from infrequent large releases to frequent small releases. So we can get to a state where pretty much every day some small thing is being released into production, either on the platform side, services, or UI plugins, or any changes or configurations. We have also moved to, since I talked about configuration, a very large amount of metadata. The amount of data-driven behavior that we have in our system today is orders of magnitude more than it used to be. Sometimes when I look at the number of configurations and data and complexity of JSONs that we have, it's actually sometimes, I think it will even be more than code. So that gives us a very high level of flexibility. Changing the behavior does not mean you have to change code, you can change data. So all this said, I think we can easily reach a stage where we are releasing daily in small bits. And of course, this can be achieved even if you don't go to the public cloud, right? It's actually orthogonal to going to the public cloud, but it has become, it's kind of come together, and we are faster and more fearless because of what Das said. Yeah.
So let me add to that. So one of the things we will quickly learn is that architects never give answer to any questions.
They ask more questions.
They ask new questions. So the answer to your question is actually a question. That when you are in the data center, what are the constraints in the data center that are driving your behavior? Right? You actually have only 200 servers in your data center. That is actually your biggest constraint. Your entire release planning, the way you deploy, the way you test is actually working around that constraint. When you move to the cloud, that constraint went away.
Yeah.
Now you have actually an infinite number of servers. You can actually create a new production environment in 5 minutes. Now, which means that now you can afford to push a button, spin up a new environment, deploy version n+1 on that environment, switch the entire traffic to that environment.
Or part of it.
Or part of it. And if it doesn't work, flip the whole thing back.
Yeah.
Right? And yeah, that is what we typically call blue-green deployment. Yes. And so one of the things that we need to build into the organization and into the engineers, okay, is to think about why they are actually behaving, why is it that they are actually operating in a particular way. And when you fishbone it down to the detail, you will discover that all of these behaviors are actually workarounds of some constraints. Yeah.
So,
Does that answer?
Thank you so much. It was very, very engaging and informative discussion. Thank you, Cynthia, for tying it all together, and we appreciate your time.
Thank you.